Hi, everybody. Thanks for coming out. I know it's been a long day. 4 o'clock. You've got taken a lot in today, and so I appreciate you taking the time to come hear me. So, a few administrative things to get out of the way. I have a few surveys that if you guys could just take one and pass it down. Just 2 questions. Just fill it out at the end. Drop it off on the back row on a seat, and I'll pick it up. It'll help me with my speaking skills. And the second thing is I want this to be an interactive session. And so if you go now to onslide.com, go to 60. I'm going to have a few surveys just interactively during our talk. And I want to solicit your input. It'll help me decide what to talk about for what length of time during the talk. So let me introduce myself. I'm Jeremy Pullen. I wear lots of hats at Cisco, but I'll just say I'm an architect. And what we do is the video that I was playing at the beginning. It's TV apps. So you never see HTML5, but I'm going to get into what really goes into doing TV. Okay, so to start out with, a lot of what I talk about here is not stuff that I can take credit for. I'm not that smart. This is work done by a number of folks at Cisco. I've been involved in all of it since 2007, but we have a number of folks who I've gotten information from, and so some credit there. Okay, so first survey. We've got 28 people online, more of you coming on hopefully. So what type of environment do you develop for the most? I just want to see what you do. Apps versus web. And I'm going to say, let me define apps. Apps could be iPhone, Android, iPad. It could be Chrome apps. It could be things like I do, which is completely hidden, but set-top box, other type of embedded applications, TV. All that's apps, okay, and we've got a number. Okay, so it looks like it's mostly web and some apps. All right, so that's good. Ooh. And you lost the presentation. All right, let's try that again. Okay. All right, so that's going to influence what I say. So next survey. How long do you expect your app or web page to run? And it's less than a day or more. In other words, if you hit refresh on the browser, anytime in a 24-hour period, you need to vote for the 1 day or less.
That's just the number of people.
Okay, so all of you expect your apps to run a long time. Okay, interesting. Most web developers that I've talked to are 5 minutes, 10 minutes. You know, that's a long time. Maybe it's longer. So let's see how we match up here. So, okay. And the last question: how often do you want to manually restart your TV or app on your phone? Never or occasionally. So maybe kind of a gimme question here, but no votes?
It's not showing up.
It's hung up. I'll have to. By the way, this is developed by Wesley Hales from Atlanta. He's spoken here before, done at previous DevCons, so should start working. He's a good guy. Okay, so, all right, so never occasionally. Maybe a little bit of a obvious gimme question, but I know I'm leading into the topic today. So what we really expect in embedded devices running HTML5 is, number one, an uptime of 30 plus days. And second, even within that 30 plus days, if something happens that goes wrong, it's expected to be self-healing. So there's some auto restart of part or all of the device where consumer isn't really seeing the failure if it occurs. So, so let's see. Let me go here. Okay. All right. So this is one of our devices. It's a just plain looking box goes next to your TV. But what you may not realize is that many devices, ours especially, have HTML5 at their core. And you're never going to see it, but it's there. So give me here a second here. Okay. Okay, so question. That is not working. Sorry. Okay, so I'm going to keep going. So question. I can go two paths here. I can talk more or less about hardening test strategies. And so this is the first vote that is going to affect the talk. So how much do hardening test strategies interest you? And I'm sure it interests everyone, but it's a lot or some. So let me give you a chance to respond if it works, and then we'll go from there. Anybody having trouble with the voting again? Yeah. Okay. All right, so it may start working again, but I will assume middle of the road. Okay. So what are we trying to find? We're really trying to find the 1 in 10,000 type of scenarios that you don't run into just running through your app the first time. And that looks like a number of things: performance degradation, abnormal behavior, unexpected handles and exceptions in data handling, any type of lost functionality. And this is the key. It's a 1 in 10,000 type of scenario where you're not going to find it very easily. And you'd be surprised how many of these exist in any app that you write. So what this really takes is test discipline. And so I'm going to breeze through this quickly because I want to get to the tail end of the talk and leave time for Q&A. But you really have to ensure you've got a clean environment. None of this is unique to HTML5. Let me see if I can go back to my previous slides real quick. Because there's something I wanted to cover, but it's not there. Okay, and it was funny, but okay. So you've got to have test discipline in order to get an app that runs a long time. That means you've got to reset your cookies, browser, take samples across test runs. You've got to do a lot of upfront setup. And you have to make sure your environments are comparable. And let me give you an example. If you have, in my environment, you've got your program guide, has a small amount of data on some days and a large on others. So if you have a movie channel, you have one movie could take 3 hours, whereas if you have another channel, it could be 30-minute programs. Your performance, all kinds of things are going to vary based on your data sets. So you've got to make sure your test discipline is using comparable data sets: server-side, network environment, etc. So there are really 3 different types of testing, and the first is long-term stability, and the purpose is to simulate normal usage. The goal is, what would a consumer do on your device or on your app during a normal 24-hour period? And then try to accelerate that. Maybe your test runs for 24 hours, but it uses your app twice as fast as a normal user would, so that you can simulate a longer time with a shorter test run. And you want to do this over a large number of devices and, again, a period of 1 to 2 days. Similarly, stress testing, you want to simulate a even faster period for a smaller set of use cases. So long-term stability is about going along the full gamut of use cases in that 24-hour period, where stress testing would be doing the same thing over and over again repeatedly. So for a TV-based application, pause, rewind, play, rewind, pause, something that's really just beating it to death. And the reason you want to do that is there are certain use cases that people do more than others. And those are the things you want to focus on. So the slides that I skipped here that had trouble with, I just want to point out, this is based off real-world experience. The products that I work on are deployed right now to millions of devices. Okay, 1.5 million right now. But the point being, this is what we've had to do over the last several years to get to this level of scale, having rigorous test discipline. It's boring, boring, boring when you just see the slideware until you start having lots of stability problems. Because the problem that, going back to the 1 in 10,000, the problem that you'll never experience running on a single run, when it gets to 1 million devices, if you have a 1% failure, that's a lot of boxes. That's a lot of devices, a lot of users that are impacted. Okay, so last, soak testing. This is the least obvious, but it's still important. How long can you run without touching anything? And it really means leaving your browser up for 30 days and don't touch it. See how long you can run without things going wrong. And once a day, go mess with it. Do a few things. Make sure it's the same things. It's a repeatable set of tests, but that you don't try to do too much. Just what would a normal user do on a daily basis? See how long you can go. If you can go a week without seeing any memory leaks, without seeing any degradation in performance, then you're doing pretty good. See how long you can go. 2 weeks, 30 days. That's what you want to get. Okay, so how do you automate all this stuff? I don't have any great answers for you here, but I'm going to talk about the categories of problems that you have to solve. So test environments. For me, is racks of physical hardware, 50 to 100 or more boxes on a rack. For all of you running, web services, web apps, it may be a bunch of EC2 instances, or maybe running a bunch of browser instances on a desktop. One way or another, if you want to scale, you've got to have the right test environment. Next, you want to have test automation tools. And I don't claim to be the expert here. I'm not going to spend a lot of time because everything that I do is proprietary. What you need to find, though, is something that works for you in your environment. So just curious, does anybody do large-scale testing of web apps? And what tools do you use? Because I want to learn from you.
WebDriver.
Use WebDriver? How about you?
Custom testing frameworks, but they're open source and as well.
Custom meaning what type of?
Running lots and lots of HTML5 applications running on many devices.
Okay, but it's custom.
Yeah.
So that's one of the challenges. Is this is not really something typical web development focuses on. How long can you run? So the practices are pretty common in some domains with embedded devices and other areas, but it's new to the community of people who need to learn about it. That's where the tool support in HTML5 specifically is pretty, it's pretty thin, and a lot of what we've had to do, again, is proprietary. Okay, so know your web engine tools. So when you're running these tests, collect data. Figure out how to do one of two things. One, figure out how to automate the generation of data. For instance, with WebKit, you can turn on extra console logs when you run it. But just the simple, okay, run 50 times or run 50 instances for a day. Find the one that's acting up and then go attach the web inspector to that. That'll tell you, pretty much everything you need to know. If you want to automate data collection over a large number of instances like we do, we've got control of the browser, so we can go instrument the browser. In your case, you might want to scrape the console logs and do some analysis on that. Okay, so one other thing is your web engine behavior can affect long-run performance. And let me talk about this. So when you're running a stress test, your garbage collector has a different environment than it may be tuned for. In a normal environment, the garbage collector can run every so often, clean up. But if you're running a stress test where, let's say, you're simulating a key press every 10 seconds, that may keep the garbage collector from running as often as you would expect. And so even though objects are marked to be freed, your garbage collector frequency will be less frequent, and you can hit upper memory limits of your platform. Same way with your graphics cache. If your graphics cache is, let's say you hit the upper limit on your graphics cache. A great use case would be a video on demand application where you have lots of poster art. Your graphics cache can have you can have unexpected performance degradation because you run out of you're used to running out of cache graphics. You go to the VOD application, you flush your cache with all this new graphics, and you go back, then you can't really do much with it. I'm sorry, then your performance goes down because it's having to reload things that weren't in the cache. Okay, so strategies for handling JavaScript bugs. There are really two approaches. You have to do both. First of all, you fix them. It's more of a brute force approach, and then you'll miss them. You're not going to get everything, so how do you have an architecture that's resilient? Okay, so typical JavaScript bugs. DOM leaks. Show hands, everyone know DOM leak? Deal with DOM leaks? I'm not going to cover that in detail because I think it's pretty commonly known. Timer storms, in talking to folks, is less commonly known. I'm going to show you an example in a second. And then dangling callbacks, I think that is also hard to solve, but pretty well understood. Exceptions I haven't run into, at least in terms of it being a common problem, but beware of your libraries because they have all of these problems. And so when you want to scale, be careful about your library selection because we've run into lots of problems with certain libraries, and I don't want to beat up on any of them. Ember, sorry. So let's go through a little example. So here's a little code. So let's create a frame that has a little timer. Okay, not rocket science here. Start a clock. Okay. All right, that's easy. What you can have, though, is a timer storm won't always be obvious. You don't always have a tick count on your clocks, for instance. All you have is the time showing up on your screen. So let's say I just clicked on Start Clock again. Now I've doubled my tick count because I didn't clean up the previous timer driving the clock. Let's do it again. Now I'm getting a little faster. imagine this is a use case where your timer is, you're switching between one application to another, and you're starting your clock every time you switch between apps, or switch between screens. You've got screen 1 and 2, one app, and you've got a clock on each one. So you don't always want to have clocks running on all the things that are hidden. So you start that clock each time you switch to that screen. Well, this is the bug that I ran into because every time we hit pause, rewind. Actually, pause, rewind was the DOM leak. Every time we switched apps, the clock was being recreated. So we've run 400 times now, just over clicking start clock a few times. If you think about what normal users do, you can get into a really bad situation very quickly just by not cleaning up your timers. So there's something that you may not pick up on here, but this is actually one of the patterns. It's killing the frame. Okay, it's gone. Okay, so let's talk about other brute force techniques. Right now, you can't rely very well on window on error for exceptions. I've talked about the other cases briefly. Window on error, not reliable enough to trust it 100%. So we're using it a fair amount, and some exceptions get handled, some don't. It's not 100%, so be careful of that. Okay, so next survey should be working. Let's see. Try this again. Okay. It's not working, but let me ask you, show of hands, how many lines of JavaScript do you have in your web apps? All right, and it's less than 50,000 lines or more. So show of hands for less than 50,000 lines of code. Okay? The next things I tell you may or may not apply. More than 50,000 lines of code. Okay, what I'm about to tell you next definitely applies to your situation. Okay, so resilient application architectures have a cost, but they're also important. So there's a fundamental concept here. Number one, you break a large single-page web app into a number of small, what I'll call micro apps. Okay? The second thing is you run each micro app only when you need to run it. And that means you manage your app lifecycle. Within a single-page app, certain things are only running when you need them. And then you pick a sandboxing architecture to supplement that. So let's talk about application architectures, and there are really two categories here. There's native sandboxing and there's HTML5. Okay? The native platform app management is what you get for free on Apple or when you're running in Chrome. You know, you write a Chrome app, it can talk to another Chrome app by web intents. And the advantage of that is you can segment a large app into separate apps. So that's pretty obvious. But there's a downside to that, and that is you don't have a cohesive user experience across those two apps. So the other thing you don't always get is the ability, if an app starts acting up, to handle that in a way that you have control over. So if you have an app that's eating up CPU or memory, relying on your native platform doesn't give you the ability to restart, for instance. So there's limited control, limited benefits to whatever you have on your native platform. And again, for big apps that you want to segment out, but have a cohesive user experience, you want animations from one key press to the next, all this stuff, you can't rely on doing that across native apps. So how do you do this in HTML5? There is a cost to it, but who's familiar with the Iframe Sandbox option? Okay, a few of you. Let's do a quick overview of it. So the Iframe sandboxing is designed to protect you from others. So you can include an iframe, but why not use it to protect you from yourself? There's a negligible performance impact or memory impact. I can't measure it. Just creating a sandbox, Chrome about memory, no change. And there's some research articles from Devdatta Akaway about using this for security-related sandboxing. But you can do the same thing, again, to protect you from yourself. So so W3 Schools, let me just show you a few options. So iframes by default don't have sandboxing. But if you add this option to allow forms, it turns on security, but then you can open it back up. So you can say allow forms, same origin, scripts, top navigation. And you're going to need some of these if you want to do it for your own application purposes. There's another option called seamless that works semi-okay, but one thing interesting is that CSS can be applied hierarchically across iframes without you having to do anything special. And if you want to do something more advanced, you can still insert your CSS dynamically from your parent page, or you can do it statically by just linking the same shared CSS from the parent and the child iframe. So you've got a lot of flexibility around styling. And in the example that I just gave a second ago, almost there. This is exactly what I'm demonstrating in the timer storm example. It's a child iframe with a sandbox option. I've still got great performance because I killed the frame, and I can create a new one and start the clock all over again. So this is actually an example of the first pattern. And the first pattern is an iframe bootstrap. All you've got to do is what I did in this page, is you wrap your application with an iframe, and if something goes wrong, you can completely clean up after yourself and restart without having to rely on Chrome to restart it for you. It's not rocket science, it's just a few lines of code. And this is where this may not seem like it may not be something you're familiar with, but it's very common in distributed, embedded type of environments when an error occurs to be self-healing. And this is just a simple implementation of it. If any error occurs, reload. Or let's say you have an app that's sitting there idle, and it's been idle for 30 minutes. Do this in the background where you're sure that you're always going to have a fresh instance. So it gives you a way to hit the refresh button for yourself without the user ever even knowing it. And you just have to save a little state off if you want to keep a state. Okay, so yeah, that's a little bit of a cheat. It's an automatic refresh that you control yourself, but it does give you full control over your memory. If you have a memory leak, if you have a timer storm going on, if you have dangling callbacks that aren't getting cleaned up, you've protected yourself from them in terms of a long run time. Yeah?
Jeremy, how would you know that one in this frame to there was a key problem, like a kind of JavaScript, you know that?
Well, you don't have to know. What you can do is you just do it proactively. Yeah, you don't even have to know you've got a problem. You just, okay, if you've been sitting there idle for 30 minutes, you know, put a screensaver up, and refreshing the page should be faster than the user ever noticed it. And that just gives you a way of cleaning up automatically, proactively. And so for a device where you don't even have a refresh, then that's really nice. And you don't have to do anything real complicated. So it's a very simple approach to doing refresh for yourself. And this is a standard practice in any type of like military device. You know, if they're required to reboot certain military applications every 24 hours, and that's actually been the cause of like folks, missiles not being shot down, is because folks didn't follow standard military protocol. In a self-healing app, just do this. It's not hard. It's just 10 lines of code to really manage that. Okay, so it's easy to do this, but maybe you want something a little more robust, a little more resilient. Okay, so let's take this to another level. You can take your application, it's already split up into micro applications, and you can split it into multiple iframe sandboxes. This is what you want to do when it's not okay to restart your whole app. When you have really large apps, the app that I just moved off of a project, the app that's deployed, 173,000 lines of JavaScript. I'm not talking about HTML and CSS, that's extra. We're closer to 225,000 lines of code. Not minified, I know, but still, that's a lot of frickin' code to run in a single web page. So there's other reasons not to do the single iframe approach, and that's where you got a high data and network overhead to restart, and you don't have web storage to rely on. It's also just the user experience isn't quite as good when you have to restart the whole app. And it makes your app framework more complex to do this. But there are still good reasons to do it. Okay, so what this looks like is you have some core management logic in your root page, and then your micro apps are segmented with clearly defined interfaces, typically using an event-based interface. And each micro app would be wrapped in an iframe. And you don't have to take an all or nothing approach to this. You can just take an app and take certain critical pieces that may be more, let's say you have problems, you do it reactively. Okay, we're having problems here, let's wrap it in an iframe to increase our uptime. Or you can do it proactively, picking certain parts and splitting them out. Then you use post message to communicate between your frames. And then you control your micro app lifecycle based on the app. Some would run a long time. Some would only run when the user needs them and could be loaded on demand. Okay, so there are some limitations to this. First of all, there is a memory hit, performance hit, where duplicate files have to be loaded into each frame. And that's where you've got to pick something reasonable for what you split out into a separate frame and have your dependencies relatively small. And there is a small amount of extra work to proxy communication across iframe boundaries, but it's very small. It's more of, it's not a performance hit, it's really just code you've got to write. But it's not hard. So I do have an example here, and anyone familiar with pure MVC? Hands? Okay, it's worth looking at. It's a very simple MVC framework that very lightweight, and we like it a lot better than Ember. So what we've done is this is by Aaron, who's on our team, and we took the pure MVC Sample App, which is just a simple reverse text type of app, and we decided to replicate it and then let them communicate to each other via iframes. So this is a test, okay, and let's reverse it. Oh, okay, and it showed up in the other frames. So let's reverse this, we type, and it should detect palindromes here, so race car. Okay, so we've detected a palindrome. So all it does, pretty simple, but it communicates this state between all of the apps, and this was done with about 100 lines of code. So the core MVC app wasn't changed really at all. We just added a new component that mediates the communication between the frame boundaries, and this code's all up available on GitHub. So let's see. Okay, so time check. So basic conclusions. Number one, test the heck out of your apps. 2, you got to watch out for the key bugs that I listed previously. Timer storms, DOM leaks, and unhandled exceptions. The first 2 are the main ones. Break your large apps into micro applications, and then manage their lifetime to be as short as possible, and where you can clean up each app individually during that lifetime. And then use your native sandboxes where appropriate and communicate by web intents. Or when you want to have a cohesive user experience between all these apps, then use iframe sandboxing as a way to make sure that your JavaScript runtime is kept clean. And then finally, it's really easy to modify your frameworks. The pure MVC example, again, is on GitHub. It's really easy to modify your frameworks to be iframe friendly, and submit those pull requests back to the core framework, and it might make it in. So again, I wanted to leave a few minutes for questions and answers, so we got about 10 minutes. If you could please fill out your the survey, and if you have a question, please come up to the mic so I can so everyone can hear you. Questions, comments?
Hi. Just the first point with respect to testing the heck out of your web app. When you say testing the heck out of it, are you talking about a full stack test from front end to back end where you do a full setup teardown? Or are you just talking about the web app as a component in and of itself?
I would say both, but if you're going to have to pick between one or the other, then test full stack. Because
all right. So that leads me to my follow-on question with the full stack. When you're dealing with the back end part, are you given a test environment where you completely tear it down and set it up? Or are you working with a testing environment where you kind of scrub data and put data back in?
At least we have different products, but typically our goal is to abstract out the back end as well. And so where we can mock out the back end with standard test data. Mm-hmm. And so different products can test different environments, but that's the goal, is to abstract out the back end if possible. But there's a caveat there, because some of your variability is based on the data. Mm-hmm. And so you want to make sure that you can get a good uptime with the standard data sets, but then you want to go to a full set, a full realistic test using live data, yeah, because that data set might vary in a way that causes you to have a stability issue.
Mm-hmm. Cool, thanks.
Hi again, I have another question, and I assume if you're doing a set-top box app, it's a hybrid. You're not running a regular browser. You have a shell with WebView. So I just was curious why, and I'm going to answer a little my own question, then I want to get your thoughts. Why is it not native code that's monitoring heap and doing stuff and killing and restarting the app? I assume you're doing that. And just the example for us, we do all hybrid apps. We watch heap and we get 80%, we restart. But the two tricky cases is, one is we had to create a heartbeat in JavaScript so that maybe there's something on the screen, but we didn't hear back for too long, and then we restart, no exceptions. And then the third thing is we even had cases where we never really found a good solution for sometimes like there was an animation that covered the screen, the user just can't tap and it's still giving us a heartbeat. So we've never really cracked that perfectly so we finally had to put just a refresh button where the user can override. So I was just wondering if your thoughts of using a hybrid environment, monitoring your app and keeping it alive.
Yeah, absolutely. It is hybrid. We control our browser and we can customize the heck out of it. But you really have to have both. So yes, we do restart on on memory leaks and all of that stuff. Right. Our native platform has that. But the point is the user experience gets affected. So if your native platform is having you restart the entire browser context and reload all 173,000 lines of JavaScript, the user isn't going to be able to watch the football game during that time. So if you have a problem in part of your JavaScript application, let's say it's non-critical, maybe it's your weather application, why can't you restart that without having to restart the whole web context? And that's where iframe sandboxing can give you something.
So what other detection do you do besides heap? Do you do a heartbeat or any other kind of things to make sure the app is still behaving, even if it might look? So
there is a heartbeat tied to the event loop on the launch product. We're working on our next product, and that's coming. But there are some missing tools in JavaScript in terms of tracking the amount of memory used. And so that's something where we will probably have to extend the DOM to give us some of the debugging and detection capabilities that everyone else may not be able to use. But there's some standards proposals, or kind of pre-standards proposals out there, I believe from Firefox. I forgot. But there are some rumblings of adding to the standard the ability to measure the browser memory.
Yeah,
and when that becomes available, then by all means use it. Until then, we're having to extend the browser.
Okay, great, thank you.
Yep. Anyone else?
Could you shed a bit more light on inter-iframe communication? Is it involved server-side to do this or not? Interframe communication.
It's all client-side. So you can do everything server-side that you want to using...
I'm asking, is it really use server-side to do this communication between iframes or not? Is it all in browser? You could, if you wanted to. I wouldn't, because you already have that post-message interface between the iframes. It's all local. Mm-hmm. But could you send something up to the cloud somewhere and then come back down? I don't see a reason to do that, but I guess it's definitely possible. Yes, that's why I'm asking, because I also don't see a reason. So
I wouldn't recommend it, but you're adding a bunch of overhead where you don't need it, because post message between the iframe boundary is pretty much free.
Mm-hmm. Okay.
Anyone else?
So what would have happened if you hit that throw exception button in your example?
Right now, it would just be ignored because Chrome is very forgiving. Yeah, that was something that I have a pull request that needs to get pushed up for me to make that handled. But it would in a couple of days when Aaron gets available, he'll be pushing that back up, and then just monitor it, and it'll handle the exception using window on error, and then send a message up to the parent frame. Parent frame will kill the iframe. So
the push should have been up, but it's not up yet. Okay, everyone, thank you for your attention, and